Madam, later at 3:30 we got network class.
Network class?
Yeah, network lecture at 3:30.
3:30, you mean? Our class is 1 to 3, right?
Yes, supposed. Yeah, 1 to 3.
Yeah, so we end our class at 3, or maybe a little bit. Yeah.
Oh, okay. Thank you, madam.
Okay, let's get started. Okay, so later on I will answer the question. I see some question on the chat box. Okay, let's focus on our lecture 11. I think it's 11 is computer arithmetic. Okay. Okay. Okay, I just upload the lecture. Actually, I forgot. I thought I already uploaded it, but then I forgot because last week is quite a long holiday for everyone, right? Pegawai, and also the birthday of our king. So yeah, guys. So computer arithmetic. So when you saw the computer arithmetic, basically this lecture is focused more on calculation. It's quite simple. Today, what our aim is to understand how our computer works, especially on the arithmetic part, the operation. So this arithmetic operation is part of, you can find the part from the CPU, kan? Dia punya kan, one of the function of the CPU is the processing instruction, kan? Also, this is an internal component in CPU adalah arithmetic ALU, arithmetic logic unit, which is perform the arithmetic and the logic operation. Okay. Basically, we want to understand how the computer do the arithmetic operation. Itu yang kita nak belajar. Macam mana dia buat arithmetic operation. So, if I'm not mistaken, some of the calculation here is already covered in maybe in your CCN, if I'm not mistaken. I'm not quite sure. And also some of it we already covered in the earlier chapter. So, kita akan tengok macam mana dia kira sine magnitude, what is to complement, and also the basic arithmetic operation algorithm yang involve add, subtract, multiply, and division. Okay. So here, okay, number representation in binary format, kita ada sine magnitude and to complement. The sine magnitude mean the leftmost bit is to represent whether it's negative integer or positive integer. Again, then we do the two complement. Okay, I will explain using the example, so it's easier to understand. All the example is taken from this lecture note. Okay, so we try to finish maybe 10 or 15 minutes before 3, because I have meeting at 3 also dekat faculty. So this is the arithmetic and logic unit. As you know that we have 4 main component of your computer, kan? Kita just do a quick revision. So here is your CPU, here is your main memory, and here is your I/O. So basically, we already cover all these 3 main component which is connected via the system bus. Okay, system bus is to transport data, carry the address, also carry the signal, read or write. Okay, it's a communication medium between these 3 main components, and I/O is the program. Here is a I/O module, or you can call it I/O controller, which is all your devices, external devices. We call it peripheral devices connected through I/O. So I/O here is I/O module become an interface between the CPU. So because CPU is processing the data and instruction, so all the data, instruction, the programs must be loaded into main memory first. Even though it's on the fly, maksudnya sekejap tu dia kena load dalam memory. So the CPU will fetch the instruction or data. When they're fetching it, it doesn't matter whether it's a job, data or instruction, dia tak kisah, dia ambil je. It will fetch it, of course, via the system bus. So when they fetch it, it's brought back to the CPU to be processed. Okay, dia akan brought back to be processed. So the process, they need to decode. So dalam CPU ni ada their own component, internal component, which is one of this is ALU. Ini yang kita nak belajar. Also, they have register, they are the control unit. So yeah, this is the internal component. As for today, we're looking at the ALU, arithmetic logic unit. So basically, we want to learn how computer perform the mathematic operation. So kita akan tunjuklah macam mana cara using pencil and pen. Okay. So yep. So basically, you dah cover all this main component. Okay, thus the calculation is ALU. Everything else control unit register. The register, you know, that is to hold the data temporarily. Register to hold something. What they're holding is a data. Data can be a number or integer. Okay, and in the computer is the service LU. Data are brought into the LU pro processing, and the result took back out to the main memory. Okay, dia akan restore balik, dia akan store to the accumulator. Ingat tak yang example yang 3 plus 2 masuk ke AC, tu kan, ingat tak yang 3 plus 2 you get 5 kan? So masuk dalam AC, masuk dalam, you have to load to AC, you store to AC. That's the basic operation. So handle integer in the form of binary. Integer, of course, computer only understand binary. So may handle floating point, okay, real number, for example, that we have 0, 1, 1, 1. Kita belajar kan macam mana nak convert. We already learn this, I think, in lecture 2. Maybe separate from this coprocessor. If you have having a more than one processor, maybe on chip separate. This is just much important, yeah. Okay, because I want to focus on the calculation part actually. Okay, this is your ALU. It's part of internal component of your CPU, control central processing unit. So the register here to hold the data. Okay, data presented to LU in register. Dia kena ada satu tempat nak simpan the data lah. Data here is a number lah, number. Okay, it's a part in the binary representation. Okay, okay, the register. When they after the processing it, they want to produce the output. Okay, and operation are stored in the register as well. Okay, here I will explain using the example easier to understand. Okay, here. Okay, kita pergi kat sini. It's a very I really hope you guys still remember how to calculate this. Kan kita dah belajar kan? Ingat lagi tak how to kira benda ni? So you divide into 2, then you must know the. Yang kita dah belajar, saya akan go very quickly into the direction of the position of the bit. So here, remember if the positive ni, I can start with position number 0, 0, 1, 2, 3. Okay, kat sini ada sign magnitude, the minus sign. Okay, so you add it up. So 8 plus 4 plus 1, you get 13. And the floating point. And here is the very important part. So you start with position 1, 2, 3, and 4. You don't start with 0 after the floating point here. So 1 divided by 4 plus 1 to the power of 4 is 16. So you will get this in decimal lah. Kalau dalam bentuk 0 hingga 9 is a decimal representation. So you get this. So you carry the sign. Okay. Okay, computer only have 0 and 1, which is a binary format. Okay, positive number stored in binary. For example, 41. Okay, kalau dalam 8 bit, so you just add it up, you will get 41. You can check it on your note. So dapat 41 lah. 1, 2, 4, 8, 16, and 32. 32, you plus with 8, you plus with 1, you get 41 in decimal lah. So this one is no minus sign, no period. No period maksudnya tak ada yang floating point. There's two types of integer representation. One is Sine Magnitude, and another one is a 2 complement. Okay, we're going to study these two. Okay, the Sine Magnitude is you look at the most significant bit which is on your left. So whether it is 1 or 0. If 0 maksudnya positive. If 1 means negative. Okay. Then later on we learn how to do 2 complements. All right. Okay, leftmost bit is a sign bit. The leftmost bit is a sign bit. For example, I give you example here. Goes okay. The leftmost on your left. Okay, is the sign bit. Sign is either positive or negative. Okay. So here 18 or negative 18. So you look at the sign bit. Yang paling hadapan lah. So here it's a 1, 2, 4, 8, 16. You get 18. So the sign is 0. Maksudnya for positive. If the most significant, the leftmost bit is 1, so it's negative 18. So bila you nampak macam ni, maksudnya you tak kira nilai ni tak akan dikira. You don't add it up. For example, 1 kan, you cannot add it up. So 1 is a sign bit, just to telling the computer whether it's negative or positive. You tak akan masuk, tak kira. Okay. Okay, need to consider both sign and magnitude in arithmetic. So how computer deal with this sign magnitude? Macam mana they deal with this sign magnitude? Okay, the 2 representation of 0. Okay, the other positive 0 or negative 0. So how computer deals with this problem? Okay, here they give you an example. So this is how they do the mathematic operation dalam komputer. Kita nak try to understand how our computer works. Okay, macam mana dia berkira benda yang sesimpel ni. Okay, the positive number is, okay, this is Sine Magnitude now. So 1, 1 is 3. So the leftmost bit on your left is 0. Maksudnya positive. So it's positive 3. Okay. Dalam komputer dia tak faham lah 3 ni is a decimal. They only understand binary 0 or 1. Okay. So negation. Take Boolean complement. But how you want to represent negative 3 in binary? Okay. 3. Take Boolean complement of each bit of the corresponding positive number, then add 1 bit. This is the 2 step. Okay. 2 step to turn this binary into negative 3. How? You follow this step. Very easy. First, you do the complement. First, you must know the value lah. Ni 3 kan? Positive 3, but you want to have negative 3. How? So, the first step to do Boolean complement. So, the first step is step 1. Kena faham ya, sebab nanti dia akan berkaitan dengan yang selepas ni. You do the complement. So, this is the value 3. 0, 0, 0. When you do the Boolean complement, what you did is, you just do the bit not wise. We call it bit not wise. Bit wise not can bit not wise. You can check the later on the not setting. Bit wise not good. So you do the not operation. Ingat tak not operation? Ni yang first sekali dalam lecture kita ni, not operation. Not operation is easy. If 1, you convert it to 0. If 0, you convert it into 1, binary 1. So you do the first step is to do we call it Boolean complement. So 1 tukar jadi 0, 1 you convert it to 0. This is a not operation. So 0, 0, 0, 1, 1, 1, 1. Okay, this is the first step. What is the second step? The second step is to add 1 bit to the least significant bit. This is step number 2. The least significant bit on your right. No, kanan awak. So 1, you add 1 to least significant bit. Ni most significant bit. So you add 1, so you do the adding operation. Ni paling simple lah, the add operation. I think everyone must know at this point. 0, 1, 1, 0, 0. So nothing here, just copy lah 1, 1, 1. So hasilnya dah, ini adalah negative 3. This is how you computer interpret it. Kalau you do the reverse calculation, you get positive 3. Faham tak guys? This is the two step in order to get negative 3. Macam ni lah komputer kita buat. Faham? Can you follow? This is the basic one. Can I get some feedback? Boleh ha? So far can ha? So ingat ada 2 step saja. Macam komputer, macam ni lah komputer awak bekerja. Dia macam complicated kan? It seems to us a very easy negative 3, but this how your computer convert it because they only understand binary. Okay, so remember ada 2 step lah. First you do the Boolean complement, which is a not operation. You tukar kalau 1, 0, 0, 1. That's it. Then after that, the second step is to add 1 bit to the least significant bit dekat hujung. To the least significant bit is on your right. Okay, on your right. So then you do the adding lah. You add saja 0, 1, 1. Kalau 1, 1 berapa? 1 plus 1 berapa guys? Ni kita revisit balik dah early chapter. 1 plus 1 dapat berapa? Binary operation, what you get? Good lah. So you get 1, 0, 1, 1, 0, 1. So carry 1. Ni basic lah This is a basic one. Okay, now the benefit of one representation of 0 work easily later ni. Ani akan explain through the example here. Okay, but then we have some special case for this operation, which is the computer, they already know lah. So 0, 0, 0, bitwise not, bukan bit not wise, bitwise not, okay? 0, 0, 0 is a 0 kan? The computer understand it's a 0. But when they do the complement, what they get? They will get the overflow. Okay, they will get the overflow. So this overflow will be ignored. So this is a special case. So the no, negative 0 and 0 is correct lah. Sebab negative 0 and 0 is the same value, betul tak? Can you think about it? Negative 0 and 0 is the same value, right? Because you tak ada owe. For example, I owing money to someone. If saya tak berhutang dengan awak, maksudnya it's a negative 0, tak ada hutang lah. So it's the same value. So this is a special case. Okay. So 1 yang dekat hujung tu dianggap overflow. So it will be ignored by the computer. Okay. Ini special case. This is a special case. So 0 and negative 0 or 0 is the same. The value is same, kosong. Tak ada value, kosong. Kosong kan, kosong kan? Betul tak? And then there's a negation special case too. Okay. So change during the negation. Okay, dekat sini, when they do the Boolean complement and adding one least significant bit, they're giving the wrong result. So that is incorrect. So dia kena 1, kosong jugalah. Ini adalah special case yang komputer akan ignore. When they get this value, they will return this value. Okay, it should change during negation. Dia kena sama sepatutnya. Okay. Ini you kena, this is the short way, the formula of how a computer do the calculation. 8 bits complement, ini formula dia lah. Okay, kalau you nak tahu, let's see. Kalau 8 bits, okay, 8 bit to complement, if positive, this is a formula actually. This is a formula. 8 bit to complement, 8 bit menggunakan 2 complement, how they do it. So if the positive, if the number is positive, so you kira lah 1, when you add it up, when you added this value up, it give you 1 to 7, okay? So this is the short way they do it. To the power of n is the number of the bits, okay? N is the number of the bit. How many bits? 8 lah. 1, 2, 3, 4, 8. So 8 minus 1 minus 1. This is the formula. If the number is positive, okay? If the sign magnitude is positive. So to the power of 7 minus 1. So you dapat berapa? To the power of 7 is 128. Minus 1 you get 1 to 7. Inilah formula dia. Tak payah kira 1, 1, 1. 1 tambah 2 tambah 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64. So panjang lah. So this is the formula. Okay. What about if the negative sign? Ini yang tadi contohnya guys. Bila dia ada negative 1 to 8 ni, ini adalah complement, dia punya complement, jawapan complement dia. So you know it's 1 to 8, right? It's a negative. So if you got the negative sign, this is the formula they are using. So formula dia adalah ada negatif ke depan, to the power n minus 1. Beza kan, jadi tadi ada to the power n minus 1 minus 1. Here only to the power of n minus 1. So n is a number of bits. So 8. Kalau negative, you use this formula. To the power of 8 minus, 2 n 8. 8 minus 1 is 7. To the power of 7 giving you 1 to 8. Get it guys? This is a formula. Tengok dia punya sign magnitude kat hadapan. Is it positive or negative numbers? Okay. So what about this one? Now it's 8 bit. They're giving you 16 bit complement. And if you notice, is using the same formula. Kalau dia positive, you use the same formula here. N is a number of bit. Then you minus 1. Then you minus 1. Number of bit you ada 16. 16 minus 1 give you 15. To the power of 15. You kira lah 2 kuasa 15 berapa. And then you minus by 1. You will get this 32767. It's a positive. Same formula. Just a different number of bits. That's it. So what about this one? Kalau dia negative ni, negative sign ni kan. So use the same formula as this one before here, up here. Same formula. So to the power of n minus 1. N is a number of bit. Ada 16. 16 minus 1 giving you 15. To the power of 15. Here is the value. Boleh tak? Senang kan? So computer dia nak work more efficiently. Dia come out, dia use the formula. Tak payahlah the computer will do the cara pendek kan. 2 kuasa kosong, 2 so it's a long way. So this is the formula they are using if they're dealing with negative and positive. Boleh guys? Ni range dia lah. Julat dia. Senang kan? Sangat senang. Sebenarnya nota ni sangat clear, very clear. For this lecture is quite clear. You can go through, then you can able to understand. So the sign magnitude, sama ada the sign magnitude is whether positive or negative. So the positive number explain. You tengok kat ujung je lah. The more the leftmost bit on your left. Kalau dia 8 bit, kita tengok kat sini ya. And then you total up. And then you know how to do it, right? You just total up, then you know the value. Kan 1, 2, 4, 8, 16, 16 plus 2 giving you 18. Yang ni pun sama lah. Kalau 16 bit, you must look at the leftmost bit. So kalau kosong is a positive number. Okay, kalau negative number, negative macam mana pula? How you get this? Negative 18 tapi jawapan dia ni. Ni yang you kena buat when the computer dealing with the magnitude, sign magnitude and is a negative. Macam mana dia dapat value negatif 18 ni? Yang step ni, dia is involve this step. Kalau ada sign magnitude negative, you must do this operation. Okay, we must do this operation. Step 1 and step 2. First you do the complement, then the step number 2 you add 1 bit to the least significant bit. Okay. Contoh yang panjang satu je and the rest is a relative. Dapat negative number ni kan. So here is negative 18. Kalau you do the conversion straight away, you takkan dapat 18 pun. 1, 2, 4, 8, 16. Mana dah? Sorry, mana yang... Oh, ni simple. Sorry, ini 18 simple je. Tersilap. Ini 18. You don't have to do the complement because involve one single number here. To complement, move the sign bit to the leftmost bit and fill with the copies of the sign bit. Okay, dengan 1, 2, 4, 8, 16. Sama juga. Negative number are here. Okay, I want to show yang ini. Ini contohnya. Yang ini contohnya guys. You have positive 18 kan? Invert the sign bit. So here you just invert the sign bit. So complement negation rule. Take the Boolean complement of each bit of the thing and add 1. Yang ini tadilah step 1, step 2. Step 1, step 2. Okay. How to get the negative 18? First, this is the value of 18 in positive magnitude. Okay, so 001 you get here. Okay, 0001, 0010, 0 kan? So you invert the bit. So you do the NOT operation. So you invert saja kalau kosong jadi 1. So step number 1 is to do the complement. 1, 0, 1, 1, 0, 1, 1, 1. The second step is to add 1 bit to the least significant bit, paling kiri. So 1. So you do the operation lah. 1 plus 1 is 0, 1, 1, 1, 1, 0, 1, 1, 0, 1, 1, 1. So you get negative 18. Macam ni lah komputer tukar negative 18. You do the reverse order, you will get this positive 18. Nak jadikan dia negatif, you follow this step. Okay? Okay, and then the bitwise complement. Okay, if you change this back, kalau you tukar balik, you akan dapat 18. Komputer dia baca macam ni. Dia akan buat this operation. Alright? Ini sama juga. If this one, okay, you can do on your own. Yang sini you boleh buat sendiri. Sama juga contoh, tapi you kena tahu how to change the value into negative. Okay? Contohnya kalau negative 7 plus 5, kan? Negative 7 plus 5, you get negative 2. Yeah. So 1, 2, 5, 6, 7. Kita contoh lain yang lagi susah. 1, 1, 1, 1. So 1, 1, 1. Okay, how you get 1, 1, 1 here? Okay, Yang sini, okay, negative 7, okay. 1, 2, 4, 8 kan. 1, 2, 4, 8. 1, 2, 4, 8. Tapi dekat sini kata 1, 0. So how you get 1, 0, 0, 1 is first you find the value 7. Okay. Saya tunjuk A saja, the rest is you do it on your own. Negative 7, tadi dikatakan negative 7 plus positive 5, it will give you negative 2, right, the answer. So remember, your computer need to convert this value first, negative 7. How? So, 4 digit, 1, 2, 4, 8. Kalau 7, 1, 2, 4, 6, 7 kan, 1, 1, 1, 0. This give you value 7, right? But positive kan? In positive, positive number. But this is negative 7. How you get negative 7? You do the step 1 and step 2. Do the complement, Boolean complement. So, you do first, step 1 is to invert this bit. Okay, 1, do the NOT operation. So, I got 0, 0, 0, 1. This step 1, right? And what is step number 2 is to add 1 to the least significant bit on your left dekat sini. So you tambah lah. So 0 plus 1 is 1. 0, 0, 1. So here you go. You get 1, 0, 0, 1. This is the value of negative 7. Faham? Kalau dia ni straightforward. Kalau dia positive straightforward, you can 1 to 4, 4 plus 2 plus 1 is 7. If it's negative sign, you have to do these steps. Yang Boolean complement 2 step tadi tu. So now you have this value. 5 is positive, so it's straightforward. Positive 1, 0, 1, 0. So 4 plus 1 is 5 kan? So 01, 01, 01, 01. Then you do the addition lah. 1, 1, 0, 1, 1, 1, 1. So the most significant bit on your right, on your left, yang ni sini kan, will be the Sine Magnitude. Okay. Betul tak? Aku salah. Okay, kenapa dia salah ni? 01, 01, 001, betul. Apa yang saya buat salah ni? 1101. Oh, sorry, saya salah. Mana tadi? Step number 2 tadi apa? 0010. 1001. Okay, 1001, betul. 01, terbalik 0101. Okay, 1101. Saya buat terbalik. Betul lah ni. So it's correct. 111. 1110. So this is your answer. So it's negative 2. It's the negative 2. Okay, and then you can change it again. If you want to check whether kenapa dia ni negative 2 kan, then you tukar balik value dia dalam positive to check the answer is betul tak 2. So you do that step 1, step 2 again. Okay, 1110, do the Boolean conversion, you get 0, 0, 0, 1, you add 1 bit, so 110. So this value is 2. Faham tak guys? Do you get it? Step 1, step 2. Senang je. Do you get it guys? Kalau tak ada respon saya tak ni Venorika. Okay. So kalau dia negatif, you kena buat that step 1, step 2. If you want to check whether the value is correct, you do the reverse order je. So you get 2. But kalau negative 2, inilah bentuk binary dia. Okay. Yang the rest ni you do on your own, sama saja. Okay. Okay. Sebab kita nak tengok this just overflow. Overflow maksudnya bit tu terlebih. Katakan 4 bit, then the result give you 5 bits. So they can ignore the overflow bits. Kan ni kan operation dia melibatkan 2 bits, 4 bits, 4 bits. But now you have 5 bits. The result give you 5 bits. So the yang paling kan kiri tu the leftmost bit ni become a overflow. Okay, bila dia range dia lebih daripada nilai binary yang you tambah. Okay. result larger than the word size. Yeah, result larger than word size. The word size is 4 bit, 4 bits. So now you get you 5 bits. So it's larger than word size. We call it overflow. Jadi baca sendiri, ada some of information here. Ya, yang ni yang kita buat ni, multiplication. Just now we do the addition, right? It can be complex operation compared to addition and subtraction. Work out partial product for 8 digit, take care with example. This is how we do the paper and pencil observation. Kalau you do the calculation, usually this is how we do it, right? Kita belajar masa kecil tu kan. 0, 1, 0, 1, 1 multiply by 1, 1, 0, 1. How you do it is you akan multiply the rightmost bit dulu kan, dia kan 1 darab 1, 1 time 1, 1, 1, 1, 0, 1. This is how we do it, right? Sampailah habis, sampai 4 cycle lah because we have 4 bits. So this how we do it kan, satu. But how computer do it? Macam mana komputer buat benda ni? Itu yang kita nak belajar. We try to understand the basic operation of the arithmetic in our computer system. So masa kecil-kecil kita belajar macam ni. Okay, so the product is the final result lah. So 11 multiplied by 13 will give you 1, 4, 3. Okay, this is how we do it kalau kita guna manual step. So but how computer do it? Macam mana kalau komputer buat? So ni dah cara-cara dia, guys. Dia ada flowchart sebenarnya. Do we have flowchart here? Okay, here ada flowchart. Here is the flowchart. You faham flowchart ni, faham semua benda. It's very simple. Okay. Okay, dia melibatkan register. Sebab tu dalam komputer kena ada register to hold data temporarily. Okay, register dia akan hold data temporarily. Kalau the new data load, dia akan bertukar. So dia tak permanent lah. So multiplier, okay, here is the, let's understand which one is multiplier, which one is multiplicand, okay. The multiplicand yang atas ni, so this is the multiplicand is 11. In binary format, they give you 1, 0, 1, 1. The multiplier is 13. Okay, ini dalam binary format lah. So this is multiplicand and this is the multiplier, okay. This is multiplicand, multiplier. Okay, dalam komputer macam mana? Ada register. So the register Q, register M. If you refer to some textbook, I found one, M is dia letak B. So doesn't matter. B ke M ke, tak kisahlah. Tapi dalam total ni is we call it register M. Just a register number, a register name only kan. So multiplier is loaded into Q, multiplicand is loaded into M. Ini adalah register, multiplicand, multiplier Q, multiplier we loaded into Q, multiplicand we loaded into M. M and Q is a register, okay, to hold this data. Okay. Register A initialized to 0, register C 1 bit is initialized to 0. So you have 4 register now. Kita ada 4 register. Okay. Register C fungsi dia apa? Hold a potential carry. Kalau ada yang carry tu lah, yang overflow tadi tu. Okay, control logic read the bit of multiplier 1 at a time. Okay, yang ini kita nak belajar macam mana our computer do this multiplication operation. Macam mana dia buat? Okay, if Q0, ini penting ha, if Q0 is equal to 1, multiplicand is added to A. Result is stored in A, C is used for overflow lah, potential carry. C and Q are shifted to the right 1 bit. Okay, Q0. Apa Q0 ni? Q0 ni adalah position of the bit in register Q. Position kosong. Q0 ah. Jadi kita ada multiplicand is, what is the multiplicand punya 1011. So multiplicand is 1011. Multiplier is 1101. Okay. Jadi kata register A kosong, register C kosong. Okay, Q0, ni Q kita kan. So Q0 is to show you the position of the bit. Kena N ni. 0 lah ni. Q0. Q0 nilai dia, initial dia adalah 1. Okay. You kena faham ini. Ini adalah syarat-syarat dia. This is dia punya algorithm. How they do the multiplication. Okay. Okay. If Q0 is 0, you shift. Result is contained in A and Q. Okay, dia adalah step by step. If this condition, do this. If this condition, do this. Okay, ya ini adalah initial value sahaja. Okay, control logic read. Okay, if the Q0, ini Q dia position di 0 dia adalah 1. What you do? Multiplicand is added to A. You kena do the addition. Multiplicand is added to A. result is stored in A. So maksudnya adalah macam ni. Plus M, this is the operation. Kalau Q0, kalau Q at position 0 is 1, so you do this operation, add operation, then you store the value into A. Okay? Q, then what's next? After you do the addition, what you need to do is C, A, and Q are shifted to the right 1 bit. Okay, shifted to the right 1 bit. Okay? And then next apa? If, dia kata if Q0 is position 0, tadi kita ada, this is your value, 1011. Let's say the value of Q is Q0 kan? Is 0, what you need to do is, if Q0 is equal to 0, then you shift. Gerakkan ke mana? Ke kanan. Okay, ke kanan. Later we show you the example. Result is contained in A and Q. Kan, you kena faham dulu dia punya step by step ni. Bila balik ni kena baca nota ni carefully. It's very easy actually. Okay, let's use, okay, what I want to do while I'm explaining this, using this slide number 25 and 25, I want you to refer to your note slide number 23 and 24, okay? Okay, this is the multiplier and multiplicand. Kan kita ada 4 register, C, A, Q, and M. Q tadi berapa? Q tadi adalah 1011, Q adalah 1101. Multiplicand 1011. So this is the initial value dia. For register. Ni register, so you load into this register. So at first dia kosong lah. So we want to do this operation. We wanted to do 1011 multiplied by 1101. So kena ada multiplicand and multiplier. So this is the initial value. You set A to 0, C to 0. Okay. Ada 4 digit, 4 cycle tau. So ni yang you kena tengok. If Q0, yang condition dia ni, what is the next step? Dia akan tengok lah. If Q0 is equal to 1, what you should do? You add it to A. Kalau Q0 is equal to 0, you do the shift operation. So you perhatikan Q0 ni, position Q0 ni, multiplicand is added to A. Okay, Q0. Okay. Mana saya punya nota susah. Okay. If Q is 0, okay, mana dia? Okay, if Q, okay, mana balik kan? Okay, if Q0 is equal to 1, okay, kalau Q0, position 0 ni, dia position dia 1, 2, 3 tau. So Q0 is equal to 1, what should you do? Kan, multiplicand is added to A. So you kena multiplicand ni M. Multiplicand F, dia kata you kena add. Add to A. A tadi kan kosong. Kan, kosong tak ada apa kan. So you add M to A. Faham tak? Do you get it guys? You follow the step by step. Based on the condition. Okay, based on dia punya algorithm. Selepas apa? Selepas you add, dia suruh you buat apa? Okay, you refer back to your lecture slide number 33. Okay, after you add, the result is stored in Q is 1, multiplicand is added to A. Okay, store result in A. Okay, store result in A. You update dia punya result. Lepas tu, kalau selepas do the adding operation, you must shifted to the right 1 bit. Siapa yang kena shifted? C, A, and Q. Multiplicand tak payah. Okay? Sorry, multiplier tak payah. Sorry, multiplicand tak payah. So C and Q kena shift. So you shift. Lepas kita add value ni, you shift to the right. Ni ada nak panah ke sana, ke kanan awak. So, multiplicand tak payah. C and Q sahaja yang shift to the right 1 bit. So you shift lah. You shift 1 bit. So dia jadi macam ni. Kosong ke sini. 1, 1, 1 bergerak kat sini. So dia ke kanan. Yang satu dia dah push out dah. Dah kena buang dah. Multiplicand dia tak boleh kacau. Dia sama je. Multiplicand yang benda yang kita nak darab tu. Okay, got it guys? Now, the next step. You tengok balik kedudukan Q ni. Dia kata if Q equal to 1, you do the adding, right? Tapi kalau Q position 0 ni, apa dia yang terkini? Adalah kosong. Kena buat apa? If Q is 0, what we need to do? You refer balik kepada nota ni. Mana dia? Ni tadi lost lah, dia hilang. If Q is if binary in Q position 0 is 0, you only shift. Tolak je ke kanan. Ditolak ke kanan. So shift. Sebab tu tak ada adding. So tolak ke kanan. Apa yang bergerak adalah C, A and Q only. To the left, to the right. So shift. Ni tadi kan, so you shift ke kanan balik. Saya akan jadi sini lah 1. Kosong ni dah, you bayangkan you keluarkan dia kan. So 1, 1, 1. Ini bergerak ke kanan. Melibatkan C, A and Q only. Okay. So shift. Okay, now the second cycle kan. Kalau yang Q equal to 1 shift, ada tak next, tak ada kan? Result is contained in A. Q tak ada apa. Okay. Okay, lepas tu ni ke third cycle, kita tengok balik value Q at position 0. Okay, apa value dia? Okay, value dia adalah Q equal to 1. Kalau Q equal to 1, you kena buat apa? Refer balik kat sini. Q position 0 equal to 1. You need to add it. Multiplicand is added to A. Multiplicand is added to A. Sebab dia 1. Q dia 1. Multiplicand mana ni? 1, 0, 0 added to A. Sebab you akan buat this operation. So you tambah lah. 1011 tambah kepada 0011. So what you get? Jadi adding operation semua tahulah 1011 tambah kepada 0010 101 berapa tadi? 01 sorry. 1. So 110. Sebab ni dah operation dia. So store dekat A. Okay. Third cycle pula selepas 8, kalau Q is equal to 1, you do the adding operation, then the next step is to shift. Ini is added to A and Q are shifted to the right. So dia akan shift ke kanan. Okay, ke kanan. M jangan shift. So you shift ini sahaja ke kanan. So ke kanan, semua ke kanan lah. P and Q. So ke kanan lah dia semua. You get this one. Okay, lepas shift apa pula? The fourth cycle adalah you look at Q. Q yang akan menentukan what operation Q at position 0 will determine the operation. Q equal to 1. Sama juga Q0 equal to 1. Kan? Yang latest dia 1. So you need to do addition operation. So you do the operation, apa yang you tambah? F multiplicand to A. So you tambah. Okay. 0001 tambah 1011. 11 011 So you dapat jawapan ni, then you kena shift. Okay, then you have to shift. Okay, when you shift, this is your final answer. So the final answer, sebab dia fourth cycle saja, dia ada 4 digit. Okay. So bila final answer dia dekat mana? Result is contained in A and Q. A dan Q. So this is the result. Kalau you tambah 1, 2, 4, 8. Berapa jadi dia? 8, 10, 1, 2, 4, 8, 1, 2, 10, 15. Dia akan jadi 21. Dia bukan 21, berapa? 143 kan? Baik. So you give this result. Sama dengan ni. Boleh faham tak guys? Senang je kan? Dalam komputer dia buat macam ni. So you kena refer to this condition. Dia macam susah tapi senang je. Boleh? Kan? So you have to read this very carefully. Kalau Q0 is equal to 1, do this. If Q0 equal to 0, you only shift. Macam tu je. As easier as that. So tadi tu yang macam ni. So now, ini adalah dia punya